Hello, ladies and gentlemen. Today we're going to be working on reading and interpreting line graphs. Okay. We're going to learn the parts of the line graph, we're going to look at examples, and then you're going to get some practice on your own reading and interpreting the information. So line graphs can be used to compare changes over time for more than one group. We're going to take a look at these line graphs. Right? We're not going to be looking here at bar graphs today. We're going to be looking at line graphs. Okay. Line graph is used to organize information about two variables, the independent and the dependent variables, which you learned about. The horizontal or x-axis is used to show the quantity of time when it comes to line graphs, okay, of one of the two variables, and that would be the independent variable. That's what goes on the x-axis of your graph. It's a variable that you manipulate or change, but it doesn't depend on anything else. The vertical axis, or the y-axis, is used for the dependent variable. The value of y on your graph depends on the value that was chosen for x. Okay, this is a variable we measure when we're doing an experiment. Okay. You usually label your axes, that's plural for axis, with the name of the variables and the units of measure. So the overall setup looks something like this. You have a graph title at the top. It should be in a y versus x format, so that means the title of the y-axis should go first, the VS for versus, and then the title of the x-axis should go second. So here's an example. In this example, we can see that the title on the y-axis is height in inches, and the title on the x-axis is age in years. The person we're talking about is Mark, and so our title is y versus x right here. The y is Mark's height in inches, and the x is his age that's down here. We can use this graph to look at trends and to also interpret data. So let's take a look at a couple of questions. The first question is, how old is Mark when he is 40 inches tall? So if you take a look and we go up to inches here, because inches is the dependent variable, it depends on how old he is, and we follow this line all the way over to where it intersects, and we go down to our x, we can see that Mark was 4 years old when he was 40 inches tall. In a similar way, at what age is Mark when he is 42 inches tall? All right, guys. You can take a look over here. We don't have a 42 inches, but we can figure that out. So if you take a look, this main line is 40, and this next main line is 50. And if you count 1, 2, 3, 4, 5 lines, you can see that there's 5 lines, but there's 10 inches. So this means each line has to be worth 2 inches, right? So you'd have 40, 42, 44, 46, 48, 50. And so you can take the first line over, you keep on going until you connect, and then you go down to the x to see where it is, and you can see that Mark grew 2 inches in 6 months. So at 4.5 years old, he was 42 inches. So we can interpret this as well. How much did Mark grow from when he was 2 to when he was 8? So we go back up to our graph, and we're looking at the x-axis because we're looking for years. So at 2 years old, Mark was 30 inches tall. And at 8 years old, Mark was 57 inches tall. So we need to subtract those two numbers to see how much he grew. So we would take 57 inches, right? And we'd subtract the 30 inches. And 57 minus 30 gives you 27 inches, is how much he grew. If you'll notice, we have units in science. We don't leave our numbers bare. We always use units. All right, here's another example question. Okay. Read and interpret each graph below by answering the respective questions. So, number 1, what is the largest number on the y-axis? All right, so if we look at our line, we can see the largest number here is 121. But that's not what our question's asking. It's asking what is the largest number on the y-axis. And if you'll remember, the y-axis is this vertical axis over here. So if we look at the top, the highest number is 140. But again, we don't want to leave our numbers without units. So we're going to go 140 beats per minute. The next question is, what is pulse rate recorded in 4 minutes? Please take a moment to answer that question. What you should have done is you should have gone over to 4 minutes and up till you hit your line, and you'll see that your pulse rate was 110 beats per minute. Make sure you put in those units. Next is looking at it the opposite way. Pulse rate of 95 beats per minute, that's our y-axis, that's our dependent variable, was recorded at how many minutes? So we're going to have to go up here and follow our line, and we're looking for 95. As you can see right here, 95 happened in 2 minutes. And again, when you are writing answers, units. Get used to it. We do it all the time in science. Number 4, the title of this graph should be in a Y versus X format. So right now I want you to take a look at the Y and a look at the X and write down what you think the proper title should be. Exercise and pulse rate is not a good title. That's not a scientific way of organizing the title of your graph. If you chose pulse rate in beats per minute, I'm just abbreviating because science, versus, and if you go back up here to take a look again, minutes, you would have the proper title in a Y versus X format. In your Google Classroom, you are going to have some practice questions that you're going to be working on with your teacher. So at this time, please go open the practice questions in your Google Classroom and work on practicing reading and interpreting graphs.